Today's daily code problem of the day is find score of an array after making all elements, number 2593. For this problem, we are given an array called nums, and it's going to be consisting of positive integers. Starting with a score of 0, we're going to apply the following algorithm. We're going to choose the smallest integer of the array that is not marked. If there is a tie, we'll choose between the one with the smallest index, so 0 is smaller than 1, and the value of the chosen integer to score. We're then going to mark the chosen element and its two adjacent elements, if they exist, and repeat until all of the elements in the array are marked. We want to then return the score you get after applying the above algorithm. So for this problem, if we look over here at example 1, we are going to look at our elements, and the first element we're going to mark is 1 because that is our smallest element. So marking 1 and its two adjacent elements, we get rid of 1, we get rid of 3, and we get rid of 2. So these are the 3 that we marked. The next we look at is 2, because 2 is the next smallest element that is not marked. And we're going to mark 2 and its two adjacent elements. 2 does not have an element to the right, so we'll only mark the element to the left. And then 4 is the only remaining element, so we can mark 4. The 3 elements that we marked individually were 1, 4, and 2. 1 plus 4 plus 2 is 7. 7 is our score. So how do we implement this into a program? To implement this, we are going to solve this problem efficiently by tracking each number and its index respectively. So since we need to repeatedly pick the smallest unmarked integer, we will store the values and the index of each element. We will then sort the elements based on the values to allow us to pick the smallest unmarked element. So we can use something like a queue, like a minimum heap or a priority queue, where the smallest number, will be at front paired with its index. So in this case, 1 is at index 1, and then we have 2 at index 0, and then we have 2 at index 0, 1, 2, 3, 4, 5, so on and so forth. So we will store them in a minimum heap, keeping the values sorted from least to greatest, and then we will mark the elements as we update the score. So we'll use a Boolean array to track which elements are marked, and as we process each element, we will add its value to the score. So let's go ahead and jump into the code and see how we could do this. First thing we're going to do is, so I broke it down into our 4 steps. We're going to store our values and indices, sort the elements, mark the elements, and update our score, and then we'll return our score. So let's go ahead and do that. First things first is we will identify the length of our nums array as value n, simply to make our code easier to read. We will then also initiate a 2D array called RDP, which is simply going to be a way for us to store each value and each position in this 2D array so we can sort them later on. So we'll have a new integer 2D array. Our first length is going to be of n, and the second length is going to be of 2 because all we have is the value and the position. Those are the 2 indices on the for each indice n. We will then update each value to be within this DP array and give it the value and the position of each value, of course. So for each integer I is equal to 0, as long as I is less than n, I can increment. And dp of I of 0 will be equal to nums of I, the value, and dp of I of 1 will be equal to I itself, or the position of the value. We'll then move on to our second step, where we are going to sort our elements. And we'll do that by using arrays.sort. We're going to sort our DP array. We're going to take one element A and one element B from the array. We'll use a lambda function to define how we're going to sort these elements. We will sort them by getting the difference between A of 0 and B of 0. Basically, this is saying we are going to sort an element A and an element B by judging if element A is greater than element B. If it is, element A will come after element B. So we'll sort it from smallest to biggest. Our lambda function is simply defining a smaller function that will help us sort this array. Moving on to our third step, we are going to define a Boolean array, which is going to basically say if we have marked this position or not. As that is part of this equation, we have to mark all of the elements before we can return our final score. And so in our Boolean array, we are just simply going to go through each integer array in our DP array, and we will take the value, and we will take the indice, and we will check if it's been marked already. If it hasn't, we will mark it. So if not marked indice, then the result will plus equal our value. That is because we are adding this current indice we're looking at to our result, which we need to actually define right here. So we're going to have a long result, and that will start at 0. But basically, we have to remember that we are also updating our result, as well as we are going to mark the indices next to the indice we're looking at. So if marked of indice is equal to true, then we need to check if it has neighbors, and if it does have neighbors, we will mark those neighbors. So if indice is greater than 0, meaning that there's an element to the left of it, we will update marked of indice minus 1 to be equal to true. And if our indice is less than n minus 1, or the last element, then we will update the element to its right. So indice plus 1 is equal to true. And that's it. That will simply go through each element, mark the elements to the side of that element, and we'll end up with our result. We can then simply return result. So if we run this, pass our test cases, and if we submit it, passes all our solutions. Thank you. Follow for more daily LeetCode solutions, and check out the links in my bio if you want to learn how to code today.